Today we're going to continue talking about graphing equations in slope-intercept form. So at the beginning of this will look familiar because we did 3.5a when we talked about slope. So if we just kind of scroll through all of this, I'm not going to refill all this out. We covered all of this, remembering slope is rise over run, remembering how slope helps us determine our steepness, and it's the change in y's over the change in x's. And it basically tells us how to get from one point to the next. This video is going to start now with using what we call slope-intercept form. So we already talked a little bit about standard form. Remember, standard form was ax plus by equals c, where we could easily use that form to help find our x and our y-intercepts. Well, the slope-intercept form, which kind of hopefully makes a little bit of sense, is going to actually help us find two really important pieces. So when I look at slope-intercept, we would see it in this form, y equals mx plus b. Remember how in 3.5a we talked about how m helps represent slope. We also have this b at the end, which is always a constant. Okay, so it's just a regular number with no variable next to it. We still have the x's on one side now and the y's on the other, but notice how we have solved for y, which kind of helps when we were talking about rewriting equations and solving for y when we had two variables in our previous lesson. So the thing about slope-intercept form, and this is obviously where the name comes from, the m is going to be our slope, and that's the constant sitting right in front of our x term. The b is going to represent our y-intercept, and if you remember, the y-intercept is sitting on the y-axis at 0, something, wherever it's crossing. So it is not helping us find the x-intercept, and that's important to notice, but it is giving us the y-intercept and the slope when it's in this form, y equals mx plus b. So when we have a linear function written in this form, y equals 0x plus b, notice how the 0 in front of this x would cause the x to disappear, and it would just give us something like this. Then we call that a constant function. And I'll describe why that's happening in 1 second. So a constant function. Constant meaning that it's always going to be that number. Y equals whatever number it is that's crossing the y-axis. It's also a constant function because it is a function. These, remember, are your horizontal lines. And remember, the horizontal line is a function because it passes the vertical line test, where the vertical lines would not be a function. Okay, so that is a constant function. Y equals just a number. So now we want to identify the slopes and the y-intercepts. So first we want to do is look at the form. We want to see, is the equation in this form? Okay. If it's in that form, then this is very simple, and I just have to pick out the numbers. So looking at the first one, would you say that this is y equals mx plus b? Looks like something times x plus or minus something with the y all by itself. So with that in mind, we have our answers. We will first do the m. M is sitting right in front of the x. That is my slope, so the slope is a 3. Then I would look at my y value at the very back. That is the y-intercept, and the y-intercept is at -4. Or you can write 0, -4. I'm going to rewrite rewrite that negative 4, the 0 part here. Okay? Now notice I have a negative in front. So if you look at the form, y equals mx plus b, the only way this plus becomes minus 4 is if a negative 4 was there. Okay? So we have to make sure that we bring down the minus as a negative if it's a minus something number. So on to the next one. So this is one of those constant functions. So what is the number in front of the x? Well, really, I could rewrite this as y equals 0x plus 6.5. The slope is not 6.5. The slope is actually the 0, which we said would be the slope of a horizontal line. The y-intercept, which is here the plus b, that's your y-intercept, and it's at 6.5, or 0, 6.5. Now this last one, we have to ask ourselves, is it in y equals mx plus b? And obviously it's not. This is where we want to use those skills that we worked on in the previous section, where we rewrite the equation and solve for y. So my first move is to say plus 5x to bring the x's away from the y first. Remember to bring down everything that's left over. And again, this is why we wanted you to write the x's first, because it's starting to look like that y equals mx plus b. Now again, I have a negative y. So then I need to divide everything by the negative 1. That'll turn this into y. Negative 5x plus 2. Now it's in slope-intercept. So if it's in slope-intercept, my m is a negative 5, and my b, or the y-intercept, is 2. So next we want to graph. So this equation, 2x plus y equals 2, is in standard form. So we certainly know how to do that. We could definitely find the x and the y-intercepts, plot those 2 points, and graph. But this is saying to use the slope-intercept form. So again, to use my slope-intercept form, I first need to rewrite my equation. I would subtract 2x's from both sides, and I get y equals negative 2x plus 2. Now, this is where this can be a super easy way to graph. I can definitely make a table, and remember we made our tables with 3 x's that you plug in, run it through the equation to get the y's that match them, and then we plot those points. But see how much easier this is. So when I see negative 2x minus 2, my initial point that I'm going to plot is right here, my y-intercept. So remember, the y-intercept is not just the number 2, it's really an ordered pair, 0, 2. So my step 1 is to plot 0, 2 on the graph. So there is my initial point. Sometimes we make the mistake of thinking that we always start at 0, 0, but this plus 2 is when x's are 0, 2 comes out, so we actually start at 0, 2. So now I'm going to use this slope of a negative 2. Now I want you to remember negative 2 could be 2 things. I could go down 2 and right 1. Or I could go up 2 and left 1. So there's 2 ways that I can think of a slope of a negative 2. So let me just show you both ways. So the left one, if I came from the green dot down 2 and forward 1, it would land right here. Right? So from here, I go down 2, forward 1. Now, I could continue that pattern if I went down 2 and forward 1 and down 2 and forward 1 to get 3 other points if I wanted to. But I also could go the other way. So I said the other way to do this would be to go up 2, backwards 1. And so notice by doing that, I would land right here. And I could do it again one more time and land right there. Now notice how all of those points are in a nice perfect straight line. So I should just be able to draw my nice arrow through all of that to get 2x plus y equals 2. And that's by using one point, which is my y-intercept, and then using the slope, the rise over the run, to help me find the next one. Now the other thing that it asked me to do was to identify the x-intercept. Well, where is the x-intercept? So in the black marker, x-intercept is where it crosses right here at the x-axis. So my x-intercept is at 1, 0. And that would answer that question for that. Obviously the standard form, it's already in standard form. We could have found those two intercepts pretty quickly and drawn that line. But there's lots of times that I would rather go to the slope-intercept form, or if I already have slope-intercept form, and plot the first point, which is your y-intercept, and then use your slope, your rise over run, to find a couple more points at least, and then you can connect your line. So here's a kind of a word problem looking at graphing something from a verbal description. So as I look through this, there is no equation for me to use, but there's some key wording in here that I can use as my slope and then also my y-intercept. So a linear function g models a relationship in which the dependent variable, remember that's the y, oop, I need to make a pen mark, that's the y, right, dependent, increases, so plus 3 units for every 1 unit. So a 3 to 1 when the variable independent, which is the x, increases also. So really it's a plus 3 over a plus 1. Graph the function g when g of 0 equals 3. And that's something we'll talk about in 1 second. So identify the slope, the y-intercept, and the x-intercept of the graph. So first, let's talk about the slope. So we talk about the slope. A rise over a run. So in that first sentence, it talks about how the y's are increasing by 3. Remember, rise rhymes with y's. For every 1 unit that the x increases, so that's a 1, which means that we really have a slope of a 3. So that's step 1. Number 2. So when I look at 2, remember our function notation, g of 0, remember it does not mean g times 0. It means when the x is 0, what comes out? Remember, that's a notation for this ordered pair. And what does 0 comma something give me? That is telling me my y-intercept. So then what we need to do is graph this. So again, try to make as nice straight a line as you can. And now I can plot my first point, which is the 0, 3. That's my y-intercept. Then I will use red, and I will then plot my slope. So again, what is a 3? 3 could be go up 3 and forward 1. Remember, it's a fraction, 3 over 1. Or a positive 3 could also do this. It could go down from here 3, negative 3, and backwards 1, or left 1. So remember, a positive slope could be 2 negatives or 2 positives. And so again, I see my 3 points. So ideally with a nice straight edge, we can draw our line to get the graph. And then step 3 here says to use the slope to find another point in the line, which we did. Up top it said to identify again the x-intercept. And again, these x-intercepts, which does not always happen, but the x-intercept on this one we can see. It is crossing right here at -1, 0. I'm going to be honest, this last one's going to be a bit of a challenge just with this stylus, but I'll do the best I can to at least explain it so you have a pretty good idea of how it works. So we have a submersible that is exploring the ocean floor that begins to ascend. Oops, and at first you obviously need to know what the word ascend means. That means it starts to come up versus descending, which is going down. The elevation h of the submersible is modeled in this function h of t. So that means all of our ordered pairs are going to be t's, comma, h. T being the time in minutes, and then the h is the feet that it is the elevation. Okay, so they're giving us this function at the back here. So 650 t minus 13,000 to explain this ascension that's coming up from that point. So we want to graph the function and identify what is the domain and range, which we talked about also in a previous lesson. So let's think about it. This h of t, is it in mx plus b? And I would say it is. You could say that it really should be y equals mt plus b, because really we're not dealing with x's in this case. We're really dealing with these minutes going in. But really it kind of says the same thing. Okay? So with that in mind, my slope is 650. My b is the y-intercept. The y-intercept in this case is -13,000. Okay? So what we want to do is we want to be able to start our graph and then see where it goes from there. So for my graph, what I'm going to do is I'm going to, let's see if I can do this the easiest way possible. I'm going to draw my x way up top here. Now remember, the x is really not an x-axis in this case. It's really going to be t's. And in reality, I really should be saying that it is in minutes for a label. Okay? Now, as far as my height, so the height is actually, let's go down, we'll do a big jump here. We're going to go down by 2,000 each block. So there's 6,000. So then there's 8, 10, 12, 13,000, and that's negative, would be way down here when we began our ascent. Okay? And so this is our feet, or the h. Okay? So in reality, what we're talking about here is this would be our h. Instead of the y-axis, it's more of our h-axis. Okay? So we have one point already. So then we have to plot a couple of other points. So let's just look at a couple of points. So with our slope, I'm going to be going up 650 and then over 1. So that's going to be tricky with all these weird numbers. So here's how I'm going to do it instead. If I think about it, I'm going to make my t-axis going forward by 2 minutes at a time. Okay, so that would be 10 minutes. Now, if I think about it, instead of me using a slope of, let me just draw my thing down here, the slope 650 over 1. Okay? Because this graph is a little bit awkward in its scale, what if I did this? Would you agree that that's the same thing as 6,500 for every 10? So with that in mind, 6,500 is a perfect one for me to try to use a slope to go over 10 to get halfway from the 13,000. So again, if I was to go from that initial way down here, if I went up 6,500 and then over 10, I can plot a point, which would be about right there. And again, if I did another up 6,000 over 10, I would land right here. Because remember, those would be going by twos, so I would make it to 20. And that would help me understand where we would have gotten back to the water level. So it's not a perfect graph, but that's about what you're trying to do. Okay? So then what we want to look at is identifying the domain and identifying the range. So remember the domain and the range. Domain stands for our x values. So would you say that this is a discrete domain or continuous domain? And the question is, can you have partial minutes? Yes, you can. You can have 1 second, half a second, 30 seconds, a minute and a half. You can have a continuous number of seconds. Seconds would definitely be a continuous domain, which tells me that I would connect the dots like we did, but it also tells me that I'm going to have a range for my domain. Okay? So when we talk about getting to the water level, so the whole point of what we are doing is this is us below water coming up, and once we hit here, we've reached the water level. So my domain would be between 0 and, we're talking about our height, no, our time. It is between 0 and less than or equal to 20. That's the amount of time that we are underneath when we were submerged. When I go to my range, remember range refers to our y values, and in this case our y values are really h's, so we should use that. And what are our y values? Well, our lowest one is negative 13,000 all the way up to and equaling 0 where we have reached the water level. So that would be our domain and our range for this function. Then, just to finalize this last question, interpret the slope and interpret the intercepts. So real quickly on that, remember the word interprets. It's very important that we understand this. What do those numbers mean? Not just what is the slope and what is the intercepts, but what do they mean? All right, so the slope. In some way, how you would word this, some way of your own wording, you're basically saying that we are ascending 650 feet per minute. That's really an abbreviated way of saying that. Okay, the slope is telling us the speed or rate of change of how our height is coming up to the water. We're ascending 650 feet per each minute. The y-intercept, basically that's at minute 0. That's basically telling us where are we right now. So what you would maybe write for this one is you were at negative 13,000 feet when you began your ascent. So it's basically telling us that we started this ascent at negative 13,000 feet. And lastly, when I talk about the x-intercept, Remember, that's when our h, or our height, is a 0. So that tells us that it was 20 minutes to complete the ascent parentheses get to water level. So I know this is kind of a long one, but this is an important thing, the slope-intercept form, y equals mx plus b. The slope, which we've talked about, is an important piece. It's showing us the rise over run. The b is showing us the initial value, the y-intercept. And those are a couple of examples on how you can use those to help you solve some problems. If you have any kind of questions, please feel free to ask the next time we get a chance to talk.